Hello everyone. In this video, we'll see with using the constructor function syntax, we can do encapsulation, or in other words, how we can implement data hiding and how we can implement static variables. So up till now, we'll take up from the code snippets that we had done in the last video, which were pretty much this. Up till now, we were coding them directly into the console, which was pretty hectic to again and again reconstruct in case we have to, as now we have to reconstruct these things again and again. So instead of going back and forth and typing things again and again, now we have shifted to VS Code. And if you want to replicate this, you'll probably need only two files. This is just an HTML wrapper, which I'm using right over here. And I've added a script tag to a particular JS file that's here. And this we did in the last video, that we created a constructor function. We also saw how we can make our constructor functions safe and what do we mean by safe constructor functions. We also saw how we can add values to our prototype object using using functions prototype object prototype value object. What's that? It's quite explained in last video. So let's first understand what is encapsulation conceptually. So encapsulation refers to hiding of data from unwanted access or unprecedented access. So suppose someone has a very smooth access of our data and has superpowers to change it, then it is not very good for us in many use cases. So let's try to generate a use case for that. Let's say with weight and age, we also take a new variable in fish, that is name. And similar to age and weight, can have names here. Let's ask for the names. And story and is Nemo, and we'll save this. We'll go here, and now if we print Nemo, then we can access these names. And now what else we can do? We can modify this swim function. So this is some setup code that we are doing. You can think of, instead of I am swimming, we can leverage the name to give these functions a little personalized touch. This Nemo is swimming. So now if we call Nemo dot swim, okay, instead of this we can say Nemo dot name. So it will say Nemo is swimming. And if similarly we say Dory dot swim, it will say Dory is swimming. So far so good. But we have vulnerability here that anyone can access Nemo.name and change it to any value. Say someone changed it to Dory, and as per our hypothetical use case, accessing age and changing age, accessing weight and changing weight is permissible. but accessing name was not permissible, is what our use case is. So now we have, since we have changed Nemo's name, it's printing Dory's name here, and that we are considering as a security breach in our system. Now our goal is to this hide this name variable in such a way that no one can change it, and even if someone is going to change it, we should be the only person that gives them the power to change it. And we want to have some constraints over this. But how to do that? Because if we see the Nemo object, the property is right there. Everyone can see it, and what everyone can see is what everyone can change, right? If you can access it like this, then it is very easy to change it as well. That's what we did right now. So there is a way that using which we can actually get rid of this problem. That way is, instead of setting this property here, I'll define a getter function. So I'll say get name, and I'll put an equal to there, and I'll create a function that will simply return name. Now what we did right here is, and now we can use this function instead of this dot name, wherever we were using this dot name. Now what we did here is, it is a very clever usage of how functions work. So if you know, functions are closed with their execution context. And when I say functions are closed with their execution context, what does that mean? I'll link some video for what is execution context and what do we mean by functions are closed in description, where you can read more about it, but I'll quickly brief over it right here. So when I create a function f, so this function here will have all the access to the variables that were existing within the execution context of this function. So say here we have defined this function f, and here there was a variable 7, and we export this function f from here, and we import this function somewhere else in next file. We import this function somewhere here in next file, and we are return, either we can return a from here, or we can console log a from here, or we can play with the value a inside this function. Now when we use this function here in this file, and suppose we also have a value of a, and here it is string, what value of a this function will actually see is not this a, but this a, because this function and this concept is known as closure, and this function is closed with the value that it saw in its lexical, in its execution context, basically where it was tagged, where, so, and what I mean where it was tagged, where it was defined or packed, you can say. So this function, so how I used to remember this or define this is that every function has its own baggage of sorrow, which it carries with itself, and it has all the memories in that baggage of sorrow that were there while the creation of that function. Okay, and this a is equals to 7 is the memory of this particular function, and now wherever this function will go, whether it goes to this file or some next file, it will have it will have his own bag of sorrow with him. And now when it will execute in any file and it wants to know the value of a, and a value of a is referenced anywhere in that particular file, this a doesn't exist, but this function will have an access to a because it holds that baggage of sorrow with itself. So this is the analogy that I always use to understand this concept. So it will take this value a7 from its baggage of sorrow and will use it wherever it wants to use it. So similar concept is what we are leveraging here. Since we have defined a function right over here, instead of defining it in prototype, now we have defined a function right over here. So this function will have access to all its variables and all the variables in its execution context. So see, name is right here, and whatever control shift C, and whatever the value for name is passed, whatever the value of, and it defines and a new function is defined every time this fish is called. A new function is defined. When this is called, a new function is defined. And every time that new function is defined, that new function is closed with the newer value. At first time when this function was defined for Nemo, that function got closed with the value of this string Nemo. And next time when this function was called, it was closed with the value of this string Nemo. So every function will be closed with its own values, and every time we are passing a different value to name. That's why, and that's how when we will access this function, we won't have access to this value directly, because once this function is executed and it's pushed out of stack, it won't be there. But since we have defined this function, and this function was defined with this particular value name in its execution context, so this function will always have an access to name, but no one else will have an access to name. So this is how we can implement data hiding. We have hidden this particular data and we have ways to access it, but we have restricted its modification right now. And we can also restrict that how it can be modified. But for now, we have restricted its modification altogether. So let's see if it works or not. Let's try to run it and see if it works. If we go to browser, put it aside. Now if we call Nemo dot swim, then it works fine. And if we call Nemo dot get name, then we get the name of Nemo as well. But if we print Nemo, then we don't have name over here. Do we have name here? No, no. This name is actually the name of function in functions prototype. So this won't be that name that we are accessing. And that name is also not defined here. And this is again objects object. So it's nowhere to be found. We cannot access name. And if we cannot access a value, then we cannot change it. And let's try if we try to change nemo.name. So first of all, there is no value as such. And even if we try to change it, then we have added a new key to Nemo, that is name. And there are ways to resist this as well, if we freeze the object or do something of that sort, but we don't want that, because whenever we will access name, how we'll access it? We'll access it using the getter, and that right now cannot be changed. So this is the way we can encapsulate values while in the syntax of constructor functions. We'll also see how we can do that using classes. It's pretty easier there as well. They have made things way much easier, but this is how we do data. This is the concept that is used for data hiding in constructor functions. Okay, let's quickly see this, that if we want to make some kind of modifications, how we can make them. So say we want to make a restricted modification. What is restricted modification? That whatever value of name was previously there will always be there, but if you try to pass some new value to us, we can add it as the next part of this name. So some people have very long names. I know. So let's say that Nemo was defined initially. Nemo was defined initially dot get name by name Nemo, but later someone told that it's not Nemo, it's okay, we are returning it actually. We don't have to return it. We have to set it. My bad. So Nemo initially had this name Nemo, but later someone said, let's not give him the name Nemo. Let's give him Nemo XYZ. XYZ. But first name shouldn't change. That is our restriction. So we set it with XYZ, and now let's see what Nemo's name is, XYZ. Now if we try to set it with a newer value, KZ JGH, oh, not with get name, with set name we'll say. And now if we try to do get name, it's JGH. So it's a particular kind of modification that we have restricted it to. So no one has a free hand. And by no one has a free hand, what we mean to say is that they can only change it in such a way because we have allowed it to change in such a way. And by no means they can entirely change the value or do whatsoever they want on this value. So by doing this, we can gain a lot of control on the values that we hold within a particular object or within a particular instance of a class. So now this is getting a very good shape where we can say we are implementing classes because we have encapsulation in place. We are creating certain kind of objects again and again. Next upcoming videos, we'll see how we can do inheritance as well. Like we have created fish and we talked about having sharks as well, right? We'll have sharks, probably we'll have other kind of fishes as well. So let's wait for that. Let's remove this set name function for now. I don't see a very good use case, but we saw how we can do it because we can do it if we want. Now let's talk about what are static variables. So if you don't know what are static variables, there can be two type of variables within class and object model. So let's go to whiteboard because it also key there we also have a track of what we study if we explain something here. Either we can have instance variables, instance variables, or we can have static variables. Static variables. So what are instance variables? Instance variables are the variables that are there within every instance of a class. And by instance, what we mean? We mean object. So here, what are instance variables that we have? We have age, we have weight, and although name is hidden, but every instance of the class has its own name. So we have name. So we have three instance variables right now. And those are age, weight, and name. And what are static variables? Now, I'll give an analogy of a different example to explain what are static variables. Say we have a class of students, and every student will have their own details, name, age, and every other thing. But entire class of students can have some variables that make sense collectively. Say I want to know how many number of students are there in that class, in a particular class. So we cannot possibly store that number with every student. This is student one, his name is Himesh, and Himesh, and let's store one more variable, and total number of students in the class are 73. Oh, pretty big class, but still. So, and her name is Ria, and total number of students in class is 73. That would be redundant, and in case we have to change it, that that would be nightmare as well, because we will have to go to every student to change. So we keep a copy of such variables that is singularly needed by all the objects of class, and that represents some value about the entire class itself, and keep them in a separate place, that is known as static variable. Okay. And what could be an example of a static variable? See, the easiest example could be that we want to store total fishes that exist. Total fishes. Fishes that exist. We want to have this variable called total fishes that has a count of all the fishes that are ever created. So it could be 0, it could be 1, it could be 2. So what do you think? Where could be the best possible place for this variable to reside? So Now, as we have already discussed, it cannot reside here. So where can we keep this variable? If you have guessed that we can keep it within the prototype object, then you have guessed it right. What we can do is we can store it within the prototype object. And why? Why so? Because prototype object is shared by all the instances of this class. So if we keep a value there, then that value is stored at one place only, and it is also shared by all the members of the class, all the instances of the class. So let's see. We'll say TOTALFISHES, fishes, that is 0. And this is how we can create a static variable. Now, there can be an interesting thing that now we also want to implement this, that this total fishes should increase by 1 every time a new fish is created. So we can simply say plus plus here. So this will increase this value every time a new fish is created. Now let's go to here and say Nemo dot total fishes. You can call it from Nemo. Okay, it's not a function. So it will give us value 2. Why 2? Because there were 2 fishes that were created till now. We can also call this variable from fishes. Fish. Okay, we cannot call it from fish because it won't be there in fish. It will be there in fish.prototype actually. Fish is the class name. Okay, let's see where it resides. It resides within the prototype object of fish. And whenever we'll create a new fish, say we created gills, that is a new fish. And since we have created a safe constructor, so we can call it without new operator as well. But it's not a good practice. Okay, we did some mistake somewhere. Internal error, too much recursion. Okay. So what we did? Oh, I missed a new here. Oh, my bad. So now if we do it, it will work fine. And now Nemo dot total fishes will be 3 because we created one more fish. And say we create one more fish, gills 2. I don't have more names. So it will keep on increasing. It will increase for everyone. Dory as well and gills as well. Because it's not stored within any of the individual object. It's stored within their prototype. Where it is stored? It is stored within fish.prototype. It's stored right here. And that is why we can access it from anywhere. Now, here as well, we encounter the same problem. And what the problem is that I can anytime change this value, total fishes, to 77, and boom. Now what we want to do is we want to hide this variable as well. And definitely we can use the same idea of hiding variables that we used previously, but now we need to see how we can implement it. And FYI, if anywhere in any piece of code you want to hide variables, then this is one of the ways you can do it. Other way is using get and set, uh, getter and setter properties. That is a very different uh, way of doing achieving the same, but we won't get to there now because that is a very different topic in itself. So we'll see how we can do it using this method right now. So now we want to hide this variable. So to hide this variable, we should have this variable somewhere, and we should, so let's create this variable first of all. Say we have this variable total fishes. Let total fishes is equals to 0. And now when we have this variable somewhere, we'll have to define functions. So get total fishes, and we'll define a function here, function function. Okay, function, and what total fishes get will do is it will simply return the number of fishes, that is total fishes. And we would want to make a setter as well. It's not complete yet. I'm not saying it's complete yet. It has loops right now. So, but let's create the setter as well. So we have a setter function that we find here, and it will increase total fishes by 1. And at most, if someone wants to cheat as well, then they can only cheat it by 1. So it's not exact what we want to achieve right now, but at least they cannot change it very abruptly. And now we'll see how we can hide it. So now what we wanted to do is we have defined these functions here, and we have this total fishes in context here as well. But the problem is it is still open. It is still open in here. Here in code, I can access total fishes. So how can I enclose this 3 lines of code within a context of itself? No, not context, within an execution context of itself. I can close it using ifs, and ifs are made for this only. So let's create an if around it. If you don't know what is an if, then we can link a video of what is an if in description probably. If is an instantly created function, so that is how the name goes, instantly invoked function execution. And by creating if, what we just did is we wrapped this variable within this particular block, and within this particular function, even if it was a var instead of let, then also it couldn't leak out. And before we had let in place, that was the only possible way to lock variables within a particular execution context. But now we have let, so we have other tricks as well to play with. Yep. So now what we have done is we have created this. We cannot access total fishes directly, but we can access total fishes using this total get fish. and total set fishes function. So instead of this, we'll call total set fishes here. And we'll see how we can hide this function as well. But there are always nuances around things. So now if we go here, if we see total fishes, that is undefined as expected, and we have to say get total fishes, that is a function, and we get 2. So it's working. And if we create a new now, then it increases as well. And if we try to see that where is this value, so this value is within, so this, we cannot find this total fishes value anywhere, because in the similar way that we used to hide previous value, we have hidden this value as well. Just give me a moment. Okay. So now what else we can do is, yeah, that's most of it. That's how we can hide values. Now there is one glitch that I will tell you is still there, that we can directly call this function from anywhere. And I'm not saying we cannot come over this glitch. So if we directly call this function, it will still increase the value. It will still increase the value. As the way we have implemented it, we have not hidden set total fishes in a way. There is a way to hide it as well. I'm not saying that we cannot hide it at all. And if you want, we can do that. So let's try to do that. I'm just thinking on how to hide it. Let's say that we have this function within here. So now we don't need to, now what we don't need is, we don't need to have this variable set to the prototype of fish, and we can add it as a local variable. Since it is local variable, it will be always accessible here, right? And as accessible, and we won't need to make this function as well. What we can do is, we can set this, we can increase this variable directly here, and from here, from this particular IFI, we can return in return fish itself, and let's copy paste this line below. Pardon. And let's copy paste this line here. Now what we have done is, we have truly hidden this value, because now we cannot access total fishes or any kind of function as well, and we return fishes from here. What we will do is, we'll say let capital fish equals to this, and we'll save this. So now everything should still work fine. We have Nemo. We have Nemo dot set get total fishes, and we can see it's there. But we have nothing called Nemo dot get fishes, because that is not, set fishes, because that is not defined. We have nothing as Nemo.total fishes as well. So now it's truly hidden. And if we go and try to check if there is anything that we can look for, or any way we can modify that value, no, I don't think we can modify that value, because this value resides here, and any person who is outside of this particular context, this particular execution context, won't have access. And we created this context in such a way that our our constructor function will have an access, because there we need to access this variable, and we returned our constructor function from here to the outside world. So outside world only have access to our constructor function. So the only way anyone can change this variable is by having access to this constructor function. And if you are calling this constructor function, then definitely that value should be increased. So that's the way we can hide variables in JavaScript. So you can apply this knowledge anywhere you want to hide variables, or anywhere you want to do data hiding sort of stuff. It's a way of doing it with constructor function that we discussed here, and we can apply the same knowledge anywhere and everywhere we want. And that's pretty much it for this video. And it was a lot of interesting stuff, I believe. I'm myself quite excited to see all this. In next video, we'll learn about inheritance and how we can implement inheritance with this fish and shark model that we had previously discussed over here. So just a quick reminder that what we discussed. We discussed that we can have a fish and we can have sharks that are descendants of fishes, and that will have all access to the variables that are there for fishes. So let's jump into the next video.